I welcome you all for a brief video presentation on the topic Boolean functions. This is about the subject Digital Design and Computer Organization. Hello everyone, I am Bharath M, belonging to third semester of CSC Artificial Intelligence Department at Sri Venkateswara College of Engineering. The subject I'll be discussing is Digital Design and Computer Organization, and the topic is Boolean functions. Let us look into the presentation. First, let us see what is Boolean algebra. Boolean algebra is a fundamental concept in digital design and computer organization. It provides a mathematical framework for working with binary variables and logical operations. By using Boolean algebra, we can simplify complex logical circuits and analyze their behavior. This page will discuss the fundamental rules and the operations used in Boolean functions. Now, let us see some of the Boolean algebra operations. First is the AND operation, which is given by the symbol as described here. The description of AND operation is the operation returns true only if both inputs are true. When both the inputs that go into the AND gate are true, then true is returned from the operation. Next is the OR operation. This one returns true if at least one input is true. Suppose this or this, either one or the next input, if any one is true, then the operation returns as true. The NOT operation is usually used to invert the input value. For example, if the input value is 1, the output value would be 0, and similarly if the input value is 0, the output value would be 1. The next operation is the XOR operation. This XOR operation returns true if exactly one input is true. If more than one input is true or there is no input is true, then the value is returned as false. Next, let us see about the NAND operation. This NAND operation returns false if both inputs are true. And the last one is the NOR operation. This one returns as false if at least one input is true. So all of those inputs should be false. Only then the NOR operation returns as true. Now let us look at the Boolean function simplification. Boolean function simplification is the process of reducing a complex Boolean expression to its simplest form by using Boolean algebra rules. This simplification can reduce the number of logic gates required to implement the function, leading to more efficient and optimized digital circuits. This process involves applying Boolean algebra laws such as the identity, domination, idempotent, and distributive laws to simplify the expression. Additionally, techniques like Karnaugh maps and Quinney-McCluskey algorithm can be used for more complex functions. Simplifying these Boolean functions improves circuit performance by reducing propagation delay and power consumption. It also makes the circuit easier to understand and maintain. Instead of having huge number of gates and inputs, we can simplify it and make it with less number of inputs and less number of gates. It's easy to understand and even saves energy and more power. Next, let us go to the next slide. Here, we'll be looking at some of the simplification techniques for the Boolean algebra. For Boolean algebra, it is a mathematical system used to simplify and manipulate Boolean expressions. This involves applying various algebraic laws and theorems to simplify complex expressions into simpler forms. The next one is Karnaugh maps. The Karnaugh maps, also known as K-maps, are graphical tools used to simplify Boolean functions. They provide a visual representation of the truth table of a Boolean expression, allowing for easy identification of common patterns and simplification opportunities. Next method let us see, that is the Quine-McCluskey method. The Quine-McCluskey method is an algorithmic approach to simplify Boolean functions. It involves systematically combining min terms or max terms, that is the minimum term or maximum term, to identify prime implicants, which are then used to derive the simplified Boolean expression. And the last one simplification technique is the don't care conditions. In don't care conditions, the input are combinations for which the output of a Boolean function is irrelevant. By considering these conditions, it is possible to further simplify the Boolean expression by reducing the number of terms or literals. Let's go to the next slide of the presentation, which is on Boolean function implementation. The implementation of Boolean functions are seen in, first it is about in the logic gates. These logic gates are the building blocks of digital circuits and are used to implement Boolean functions. They perform logical operations such as AND, OR, and NOT. These three are the logical operations. We saw its description and its symbol in the previous slides. The other one is the implementation of Boolean function can be seen in integrated circuits. Boolean functions can be implemented using integrated circuits, that is ICs, which are small electronic devices that contain multiple logic gates. ICs are commonly used in the digital systems. Let us go on to the next slide. Let us look at two more possible ways where Boolean functions can be implemented. Programmable logic devices, that is PLDs, are another method of implementing Boolean functions. PLDs can be programmed to perform specific logic functions and are widely used in digital design. This is where the programmable logic devices are used. Another one is the field programmable gate arrays. Field programmable gate arrays, given by the abbreviation FPGA, are highly flexible devices that can be programmed to implement complex Boolean function. The field programming gate arrays are commonly used in prototyping and testing digital circuits. These were the four places where the Boolean functions can be implemented. Next one, we saw about its implementation. Now let us see about the applications of Boolean functions. The Boolean functions are widely used in various fields and industries. Here are some real-world examples and use cases where Boolean functions are utilized. As we saw in the previous slides, Boolean functions are required everywhere because their most important duty is to simplify the complexity of the devices. Here, let us look at a few applications of Boolean functions. The first one, it is used in digital logic designs. Boolean functions are fundamental in designing digital circuits such as logic gates, flip-flops, and multiplexers. These three are different kinds of digital circuits seen in computers. And the computer programming is also an application of Boolean function. The Boolean functions are used in programming languages to control the flow of execution and make decisions based on conditions. That is, the control flow statements used in computer programming languages are all similar to the Boolean functions. Next one is about the computer networks. Boolean functions are employed in network protocols and routing algorithms to determine the path of data packets, like the way how the data is used in each computers or in a given network of computers. These Boolean functions are required and those network protocols and those algorithms. So this determines the path of data packets, in which way the data is flowing or how much data is being used in the network. Not just three, let us look on few more applications of the Boolean functions. One is the database systems, is where the Boolean functions are applied. Boolean functions are used in query languages such as SQL to filter and retrieve data based on specific conditions. Next is artificial intelligence. The Boolean functions play a crucial role in the machine learning algorithms, decision trees, and rule-based systems. Machine learning algorithms are those used in the robots which work automatically and those softwares which have artificial intelligence. They need Boolean functions because they simplify and keep the machine working smoothly. The next application of the Boolean function is cryptography. Boolean functions are utilized in encryption and decryption algorithms, and this one is done to secure the data and ensure confidentiality of the data of the user. At these places, the Boolean functions are used. So we now looked at 6 different applications of Boolean functions. This list does not end here, but due to the shortage of time, let us skip this and move to the next topic. The next one is about the future trends in the Boolean functions. Future trends in Boolean functions are likely to be influenced by advances in computing technologies and applications. As quantum computing develops, there may be a shift towards using Boolean functions in quantum algorithms and circuits, leading to the development of new techniques and methods. For manipulating quantum states, this is used. Additionally, Boolean functions are fundamental to decision-making processes in machine learning, and future trends may involve their integration with deep learning techniques for more efficient and interpretable models. The Boolean functions are fundamental to decision-making processes in machine learning, and future trends may involve their integration with deep learning techniques for more efficient and interpretable models. With the increasing demand for energy efficient and high performance computing, there may be a focus on hardware implementations of Boolean functions using emerging technologies such as memisters or neuromorphic computing. Moreover, as digital circuits become more complex, there may be a need for new optimization techniques for Boolean functions to improve circuit efficiency and performance. Overall, these trends suggest a growing importance and versatility of Boolean functions across various computing domains. This is about the future trends in Boolean functions, how the Boolean functions can improve in the future time, or what is the scope of future for the Boolean functions. As advancements in digital devices and computers are taking place, the Boolean function will always continue to play a very crucial role in the software and hardware industry. This was about the presentation on Boolean functions. We looked at the different types of Boolean functions, where they are implemented, the different operations of Boolean functions, 6 places where the Boolean functions are applied, and the future trends of Boolean functions. Thank you very much for being through this video. See you soon in the next video. Thank you.